Have you ever wondered how network and internet works? Well, you came to the right place. My name is Philip, and today we're talking about network and internet. A computer network mostly consists of several components. It can be just a few, sure, or only two, but mostly it's several. Every component can be connected with either a cable or wireless. Some may be connected with both, such as a laptop. Some examples of components are a server, or servers, if it's depending on the amount, a router, or router, depending on where you're from, can be multiple depending on the size of the network. A switch may also be multiple depending on the size of the network. And for wireless, we may have an access point, or, of course, you guessed it right, or several of them, if it's a big network. No matter if the communication goes through a cable or wireless, we're still using the same basic transmission technology and protocol. The most common one is Ethernet. Now, data packets for Ethernet uses something called MTU, which stands for Maximum Transmission Unit. The default value is 1500 bytes, and this only needs to be changed in networks that has a specific use case. Now, the data, or data packets, contain both sender and receiver address. Every device that can be connected to a network has a MAC address, which stands for Media Access Control. This is a physical address connected to the network interface. Whether it be wired or wireless interface, it still has a MAC address. It can be compared to a social security number, and there should never exist two devices with the same MAC address anywhere in the world. I say should because it shouldn't. It's not allowed. It's not supposed to exist. Just with social security number, you can't have two people with the same social security number. It would be chaos for those two and people who would be involved, just as networking equipment that would be involved. Anyway, now this is ensured by each manufacturer having unique addresses that they can use. An IP addresses, or an IP address, is a logical address. That address is assigned to your network interface, and that address can be changed. It's used to communicate with devices outside of your local network. So as long as you're talking inside your local area network, or your LAN, you actually don't need an IP address. It makes things easier, yes, absolutely, but it's not required. An IP address is required to speak to someone outside of your LAN. Now, to do this, we need some type of router or gateway. The OSI model is considered well established in computer science and education, but in data communication, the TCP/IP model is the standard. Now, to quickly ramble through the OSI model, we'll start from the wrong order, which is from the top, because you actually start counting from the bottom layer. So layer 1 is the physical layer, and then we work our way up to layer 7, which is the application layer. Anyway, we're starting from we're going the wrong way. We're going downwards. It's downhill from here. Now, layer 7 is applications and programs such as web browsers, file transfer, etc. Layer 6 translates the application to formats that are more suited for communication. It can also encrypt the information before it's sent. Layer 5 splits up the information and make logical connections between communicating devices. Layer 4 packages the information, makes sure that the incoming data is okay, and if it's not okay, or if it encountered an error, it will send a request. Layer 3, which is probably one of my favorite layers, addresses the information to the right recipient. And layer 2 regulates the physical transfer, and layer 1 handles the physical connection. For instance, type of cable, what type of connection it is, if it's a display port or an HDMI, or if it's an RE45 for a standard patch cable, or if it's a fiber connection. Speaking of patch cables, a TP cable, which stands for twisted pair, is the most commonly used cable in local networks. Now, we have UTP, which is unshielded twisted pair, and STP, which, yeah, you guessed it right, is shielded twisted pair. With that, we have different categories which can send data in different speeds. For instance, a Cat5e cable has a max throughput of 1 gigabit per second, whilst a Cat6 cable can handle 10 gigabit per second, as long as the cable is not longer than 55 meters, which is about 180 feet. It usually only uses 2 pairs or 4 conductors for data communication, and it's normally used between computers and other network equipment, such as a switch or a router, and between a switch and an access point. Now, the connection that is being used is called RJ45, and yes, the pairs in the TP cable should be contacted in a T568B, that order, just as the keynote shows. Just thinking that as long as they are connected in the same order in both ends, that's a wrong way of thinking, because the pairs in the cable are twisted differently. So the orange pair and the yellow pair, or I don't know where yellow came from, but the orange pair, or for instance the blue pair, they are not twisted equally. So if you just put the cables where you think, oh, this is good, I'll do it like this, and then just do in the same order in the other end, I'm not saying that it won't work. I'm saying that it's not good, because it can result in different network troubles that you will have a hard time troubleshooting. Just follow the T568B. Just do it. Just do it. I believe in you. An IPv4 address consists of 4 bytes or 32 bits. It's written as 4 decimal numbers with a dot in between, and each number can be between 0 and 255. Now, there are some IP addresses that can't be used on the internet, and we'll look at them in a second, but first we'll look at some differences between IPv4 and IPv6. Now, IPv4 was deployed in 1981, so you know that's a long time ago. In 1999, IPv6 was deployed, since they realized that IPv4 addresses would run out eventually, which they did a long time ago. IPv6 is based on 128 bits and written in hexadecimal, and also it's basically an endless amount of addresses. Now, whether you're using IPv4 or IPv6, it still has to be a unique address for that local network, otherwise we'll get an IP conflict. So, back to the addresses that can't be used on the internet, so-called non-routable addresses. These are called private IP addresses, and they can be used freely on a local network, but not on the internet. They can be used on the inside of a router that has a routable address on the outside, which are facing the internet. Then we can do a NAT or a PAT, so that we masquerade our inside addresses. Now, along with an IPv4 address, we also have a net mask. The net mask tells us which part of the IP address that belongs to the network and which part that belongs to the device. The part that belongs to the network is called a net ID, and the part that belongs to the device is called a device ID. The net ID will be the same for every device on that logical network, and the device ID will be different for every device on that same logical network. If we change one part of the net ID, we'll need a router to be able to talk to that device. Speaking of routers, or routers as my English friend or kind of co-worker says, this is basically how the internet looks. A big bunch of routers or routers sending traffic between each other to different servers and clients. They are used to communicate between different subnets. For instance, if you have 2 networks, one which is 192.168.0.0 and the other one that is 192.168.10.0, then we'd have a router in between, so that we could send traffic from one network to the other. That's what's called routing or routing. There are several different routing protocols that are suited for different needs. But on the internet, the majority is using BGP, which is a short for Border Gateway Protocol. It works because every router has a table called the routing table, or route table, or route table, which contains information on what way to send traffic depending on where the end destination is. So you know when you open your browser and you go to your, I don't know, local news site, you type in the name .com and you press enter and boom, there you are, right at the source or the web page. A computer doesn't really talk names, it talks numbers. So in order for web addresses or so-called domains to be readable, instead of just remembering an IP address, we use something called DNS. DNS translates domain or web addresses to IP addresses. If the information isn't in the browser's or the computer's DNS cache, a request will be sent to the root servers first, which are at the top of the top in DNS. Then a request will be sent about the TLD or the top level domain, in this case for .com, to see who's hosting the example.com domain. com. Something that a lot of people don't know is that every domain and every web address actually ends with a dot. So for instance, example.com is actually example.com dot, and the last dot is root. Now if you don't work with DNS servers, you'll probably never see it though, because that's the only place you actually might have to type it. Otherwise you don't have to, the computer understands it. The computer knows that we don't know. Well, some of us do know, but you know. So, there may be some different devices in a network. A hub should never be one of them. Not ever. No. Just no. A switch is used to connect multiple devices together and keeps track on where every device is connected, so that the data to that device doesn't have to be sent everywhere. A router, as we've mentioned, is used to send traffic between different networks. Power! A firewall is used to protect the networks and decide what traffic may be sent through. This can also be built into the router. Access points is used to make a wired connection wireless. A server may have a lot of different functions, but normally you have DNS, DHCP, Active Directory, file and printer sharing, etc. A storage unit, like a NAS, is mostly used when a server isn't needed or if you need a lot of storage. As our last topic of today, we're going to talk a little bit about VLANs. Now, this is a functionality that are used to separate multiple subnets or networks in the same hardware. For instance, if you have 3 different departments that need their own network, but you only need 2 switches to connect every employee, well, then we can use VLANs to create basically logical switches inside a physical switch, kind of like we're doing with virtual machines or VMs. So we create logical switches inside a physical switch, so that we send all traffic between the switches with a VLAN tag, so that the receiving switch knows what VLAN the traffic belongs to, and can therefore send it to the right device. In doing this, we save a bunch of money and hardware, but we do however need a router and with an interface on each VLAN. But we'll cover that in a later video. Now, if there is something that you'd like me to make a future video about, leave a comment down below and let me know. And if you found this information helpful, or if you at least found that you learned something, please consider giving this video a thumbs up and subscribe, so you don't miss any future videos. And if you didn't like this video, try playing it again, but double the speed. See if it makes it better or worse. Until next time, have a good one. Bye!